Hello, everyone, and welcome to Freddie Mac Connect 2023. My name is Michael Bradley, and I lead the modeling and analytics group for the single family businesses. We're a shared service, so we provide models for both single family acquisitions and single family portfolio. Today, I want to discuss three things with you. First, why we need AI, and then why we need it to achieve our mission. Then I'm going to talk about some of the inherent or elevated risks that come with AI and how we believe that they can be addressed and mitigated. And finally, I'm going to talk to you about some of the examples that we can use to illustrate how Freddie Mac is already using. So I think this is really exciting stuff. So let's get started. First of all, why do we need AI? Well, we need AI to gain process efficiencies. We work better. It'll help us work better, smarter, and keep up. And keep up is something I'm going to address in just a bit, as to the exponential pace of change in AI. Second, humans predictably make mistakes. And if you think of Kahneman's book on thinking fast and slow, humans use what are called heuristics to help them make decisions, and these heuristics often lead us astray, and machines can help us so that we don't make predictable mistakes. The second major reason why we need AI is to identify new products and solutions for you all, and to help you manufacture loans that meet our manufacturing specifications. This is, in essence, to reduce the noise, and I'll provide a specific example around how this can be used to reduce our repurchase rates. Second, thirdly, I'll talk about we need it to improve decisioning, including our major models. This will allow us to increase access to credit and to produce results that are fair. Now, AI really went through a period called the AI winter a couple of decades ago, but its recent sort of resurgence is a result of the confluence of three things. First of all, big data. The more data that we have, the more that we can learn. The second is infinite computing, especially in the cloud, which encourages experimentation, especially when it comes to modeling, but also when it comes to new types of computer devices that have been made and geared specifically for AI. These chips move data much faster through the system. And finally, machine learning. Machine learning is a subset of AI, and there's been tremendous improvements in machine learning over the past couple decades. And machine learning models clearly now dominate old-fashioned kinds of models, such as statistical models or econometrics models. And they do that for two basic reasons. One is they can make sense of nonlinearities and interaction terms much better than traditional models. And secondly, they can make sense of unstructured data. Think of things like text, voice, images that traditional models can't handle at all. So this confluence of things come together with giving us a definition of AI. And this definition of AI, I want you to really focus on this because it's critical. It goes back to Alan Turing in 1950, and AI is the theory and development of computer systems able to perform tasks that normally require human intelligence. Remember that normally require human intelligence. Now, let's just talk about the pace of change. Well, it's exponential. Here's a simple example. And when you're playing chess, there's about 10 to 47th number of permutations that you can move the various pieces. So in 1997, IBM trained its machine called Deep Blue to play chess. Well, how did it do it? Well, it fed it books on how to play chess, and had the machine play chess with grandmasters. In other words, it was teaching the machine how to play chess as humans historically have played chess for hundreds of years. Now jump forward only 20 years, and a company called AlphaZero created a machine to play chess. But unlike the 1997 version, AlphaZero simply started by saying, here's the objective of chess, to capture the king. Here's how the different pieces move. And they created an objective, capture the king, along with reward systems, which means if I move this piece here versus if I move it here, which gives me more future moves, that's the preferred move. So in a matter of just 20 years, we went from encoding human type of insights in the machines to having the machines learn strategies all by themselves. This is mind-blowing if you think about it, because it goes all the way back to the days of, Martin Luther nailing the thesis on the church door, to Descartes, to Kant, to the age of reason, and humans thinking that the way that they approached and solved problems was unique and the superior method. What we're learning now is these different deep learning techniques can solve problems, but do so in completely different ways. So when grandmasters watch AlphaZero play chess, they learn strategies that no human has ever thought of when playing chess before. This is phenomenal and represents really a new method of thinking. Now, chess is fun and it's about games and stuff like that, but let's talk about some real world applications. Well, MIT in 2020 used deep learning, which is a form of AI, to teach the machine a bunch of different molecules and how those molecules related to creating an antibiotic. They wanted to create an antibiotic that no humans had been able to create. So what they did is it taught it a bunch of molecules and the relationships to their ability to fight antibodies. So in 2020, the machine very rapidly created a new antibiotic called halicin that successfully fought the disease, but did so by looking at components of the molecular structure, again, in ways that humans never thought of thinking about. Finally, let's talk about large language models, which you may have heard about ChatGPT and the like, right? These are really fascinating in the sense that they're nothing really than large language models or deep learning models, which is a form of neural network of the type that I talked about with had reward functions and the like, but they've also think sequentially. So it's not just the words as they're presented left to right, but also right to left. So if I have the expression, I went to walk the ... you're much more likely to fill in the ... with a dog than an airplane or a car or whatever. So the machines are learning to think about text in context. And that has opened up a whole new realm of possibilities. That's why we see deep learning, machine learning solutions now that can actually do translations on the fly from one language to the other. These are the same technologies that are being used in self-driving cars. And, soon they will be used for a flight of sequence of drones flying around delivering packages. So this is really exciting. And again, philosophically, it's amazing to think about there may be different forms of reasoning than what humans have historically thought about. and they have very many real-world practical applications. Now, the second reason that we need AI is because, as I talked about, humans make predictable mistakes. Let me give you a simple example. I often talk to a large group of appraisers and, might go into a conference room with 250 appraisers. Well, for a while, I would go into these rooms and I would give, everyone would receive a red envelope. But what they didn't know is they had been randomly sorted into two different groups, Group A and Group B. And what Group A saw was when they opened their envelope was, Chesterfield, Missouri is a nice suburb of St. Louis. Group B saw, Chesterfield, Missouri is a nice suburb of St. Louis. Do you think the median sales price in Chesterfield is more or less than $900,000? Then I would show them a picture of the old house when I lived in Chesterfield. Give them features, how many bedrooms, bathrooms, square footage, lot size, etc. And say, please estimate the value of this house. Well, Group B's estimates were always 40 to 52% higher than Group A. The reason why? They were thrown by the 900,000. This is a complete non sequitur. The median sale price in Chesterfield, Missouri at the time was $350,000. And you say, but why is this meaningful? Well, because if you think of an appraiser, when they estimate a sales transaction, why do they need to know the contract price? Doesn't that somehow influence their estimate of value? They can estimate value for refinance transactions all day long without that price. But when it comes to the contract itself, on a purchase transaction, they think they need that. And we're challenging them to think, why do you need that? Can't you produce your estimate without being anchored by that contract price? Now, so humans make predictable mistakes and machines can help us work smarter for sure. But it's not all, a panacea. Machine learning AI certainly does highlight or heighten some areas of model risk management. They may perpetuate human bias to the extent it's embedded in the existing data. They're difficult to interpret and explain, especially to business people who are leery about using something that they don't understand, obviously. And the machine learning platforms, some of which we have several at Freddie Mac, pose new types of risk. Because if you have people using those platforms that are not formally trained, they can come out with things that look like a model, but they really don't understand any of the underpinnings about how that model's been created. So AI certainly heightens some area of model risk. And there's been lots of regulatory guidance around AI. The FHFA has issued an advisory bulletin. Fortunately, it recognizes that AI is an evolving field and they encourage responsible innovation and use of existing model risk management practices. There's a pending white paper out there on AI ML, and the CFPB has issued proclamations saying, there's probably going to be enforcement actions against AI, especially those that are black box in nature or that use non-traditional types of data. So there are heightened risks associated with the use of AI. The road ahead really is about, can you create the transparency that's needed so that you can explain the decisions being made by the machine? And if the AI Institute at Stanford has shown that there's about a 5-fold increase in the number of research papers and investment in ethics and explainability since 2016. People in this area realize that their technologies and their algorithms are not going to be used for a lot of business applications unless they can solve the problem of transparency. Fortunately, this problem can be solved. It can be solved either by using explicit AI architectures that put constraints on the system so that you can interpret what it's doing, or you can run the algorithm and then explain how it's working ex post. And there's a lot of literature now that does this, one of which are called Shapley values, which comes out of game theory, where Lloyd Shapley won the Nobel for that by explaining how the different pieces come together to explain the final output. There's many other techniques that can be used to explain how these models are actually coming up with the decisions that they're making. So that's good news. Heightened risk for sure, but certainly the case that we can explain the decisions being made by the machines. Now let me give you just a couple of examples of how we're using AI at Freddie Mac. Well, we've been on a journey to improve our front-end decisioning model called Loan Product Advisor for a large number of years. The goal is to make it more flexible, fairer, more accurate, and more intuitive so that it can expand access to credit and be fair to both minority and non-minority borrowers alike. We have champion challenger framework. So sometimes the model may be the champion is of one type of algorithm and the challengers are different. And you pit them against each other so that you learn from the challenger to improve the champion. Data-driven model segments, and also what we call innovative fair lending techniques, which I'll explain about in just a minute. We brought the loan scoring service in-house. We acquired Experience Attribute Toolbox, which lets us take in thousands of underlying credit features and summarize those into variables that go into our models. And we acquired Zest AI's machine learning platform called XAML so that we can improve how we go about our fair lending testing. Let me explain the fair lending testing because this is really something tremendously innovative and impactful. For those of you that may not be real deep in fair lending analytics, you have to go through three different kinds of tests. First, you have to make sure you got nothing in your model that creates outright discrimination. You know, you can't have any variables in there that would include things like sex, race, gender identity. None of those variables could possibly be in your model and avoid fair lending scrutiny. Even if you don't have those kinds of variables, though, you've got to go through a second type of testing, which is called proxy testing, to make sure that none of your variables are similar enough to the protected class features so that while they're not those protected classes, they're correlated enough that they might as well be. And then once you pass those two stages of testing, you go on to what's called a search for least discriminatory alternatives. And the way that this used to be done in the old days was you'd have an algorithm, say LPA, and you'd say, I'm going to take a variable or a feature and I'm going to drop it because it creates disparate impact against a minority class, say. And I'm going to see if I can replace that with an other variable that yields substantively the same business result, but has less disparate impact. That was time consuming and it wasn't all that great. What we're using now is an AI technique called generative adversarial networks, or GANs, that smartly search for alternative model specifications. And the way that I describe this is imagine a fencing match going on. One fencer represents your core model that you built, and the other fencer is fighting for fairness. And they go at it, and they have their match. And the base model gets a little cut here, and a little cut there, and another cut here. And at the end of the duel, the base model turns out with little cuts. Those little cuts are little tweaks to its parameters or weights, a little bit this way, another one goes that way, a third one goes a different way. But it remains largely as predictive as you started out with, but it's now much fairer, in meaning that it has much less impact on protected classes. And so this has allowed us to build models using machine learning and AI techniques that are a lot more accurate because of the reasons I talked about earlier, but also a lot fairer. So we're getting, both things that we want out of these kinds of AI techniques. Let's talk about our asset income modeler, which is something that we use to manage risk. But, it's also income calculations are one of the largest reasons for quality defects and one of the highest reasons for loan repurchases. So what we want to do is use machine learning called natural language processing to read information off of bank statements and then use that information to calculate somebody's income. It removes subjectivity and manual errors. It essentially brings that whole quality control function up front in the process and makes it a QA function. And we get the data directly from via third-party trusted sources, which helps reduce fraud. So again, the AI techniques are helping us serve you better. The next thing is if we go on to Home Value Explorer, which is our AVM and is the power horse beyond our ACE offering, which is our appraisal wavering offering. HVE outputs the estimates of value for about 100 million properties throughout the United States, single-family condo, co-ops, and two-unit properties, and it updates these estimates of value on a regular basis. What's it start with? Huge swaths of data, public record data, data in the appraisal portal, MLS data feeds, information off the loan application. All that information comes together and is used to estimate the value of that specific property. And what's really interesting about it, it also produces what's called forecast standard deviation, which is sort of techie for a confidence measure about how much confidence we have in that estimate. So HVE is used throughout the organization to support important functions, and our whole emphasis is on using it to continually manage risk. And as I said initially, it's the power horse behind our appraisal wavering offering. The frontier in this space is we're already using text features to estimate things that are important. Text meaning words that come in appraisal documents or MLS feeds and those kinds of things. The next frontier is images. And so we're applying AI ML techniques to make sense of images. Is this property updated? Is it not updated? What kind of countertops does it have? What kind of appliances does it have? Does it have any apparent mold? All these things we're using together with the text and other property attributes to estimate the condition rating of that property. Text is the frontier. We're still getting there with, images is still the frontier. We're still cracking that nut. Text is already behind us, but this is really exciting, because we think this will take our capabilities to an entirely new level. So as I mentioned at the beginning, there's definitely trade-offs, right? When you're building models or solutions, you can stick with the old-fashioned stuff, the linear models or the logits or the decision trees. They're easy to explain, but they're also not very accurate. The newer methods are more difficult to explain, but far more accurate. And then the trick is to use those techniques that I discussed so that you can describe and explain and make transparent how those more complicated models are arriving at their decisions. So Freddie Mac's success with AI will require that we link the organization and upskill our employees, and that the AI algorithms, the infrastructure, by that I mean the tech, and the data all surround our single family business strategies. The other thing that will be critical is that we all be willing to work differently. Future success with AI will require our people to be willing and able to work with intelligent machines. We want people to focus on those activities where what economists call, they have a comparative advantage. That is, don't do something that's simple and that is easily replicated. That will be automated. Use the brains that you have to do creative, strategic kinds of activities that are still difficult for machines to actually accomplish. The most reliable and appropriate solutions, we believe, will result when people and intelligent machines work and learn together. Because what we learned from COVID, and we still are learning from large language models, it's best to always have an adult in the room. Rarely is it the case that you want the machine by itself, without human involvement, making important decisions. So to wrap up, Freddie Mac is harnessing the power of AI to improve decisioning, identify new products and solutions for you all, gain process efficiencies for ourselves and for the industry. Examples I gave from optimizing credit scoring, improving home valuations, standardizing income calculations, fairness and equity in lending. All these are just examples of where AI is a driving force in Freddie Mac's pursuit of its mission. Thank you, and enjoy the rest of Connect.